Welcome. If you are joining us for the Teaching with Tinkercad webinar series, you are in the right place. We are so excited to have you for this exciting topic about introducing robotics to your students with Tinkercad. So we are so happy you're here. We're just going to get started by warming up the chat, and we would like for you to explain to us. So we know that when we are talking to robots, it's really important that we're really clear in our instructions. How would you explain to your students, no matter what grade level they're in, be they in kindergarten or if they are in college, for example, or maybe it's at a community makerspace, how would you explain to your student what a robot is? So please let us know in the chat. And again, if you're just joining us, welcome to the Teaching with Tinkercad webinar series. My name is Kellyanne Mahoney. We will get started with formal introductions when we start our formal program, but for now, we're going to warm up the chat with our question about how would you explain to your student what a robot is? Really think about how you could explain it in like the clearest, easy to understand language. Randy, do we have any great explanations that you've seen so far in the chat?
Let's see. Man-made object that performs tasks that are programmed by a human. So that's one. Machine that needs commands to move. What else do we have here? It's moving fast. Sorry. Anything that responds to the environment using sensors.
I wonder if anyone's used ChatGPT to answer this question.
Carry out a machine that will carry out specific tasks in repetitive behavior. Sorry. Hold on.
And as Randy is looking at what's going on in the chat, and I know it's moving really quickly, there's a lot of you joining today, and we're excited about that. We also want to just let you know this chat is your chat. This chat is here for you to connect, not just with us, but to connect with each other. So do please feel free to also introduce yourselves to each other. This is a global community of educators, so we're really excited to hear from teachers all over the world, and for you to have the opportunity to connect with teachers all over the world. So if you feel comfortable doing so, please also let your peers or fellow teachers in the chat let us know where you're coming from, what you're teaching. So do please feel free to see this chat as your chat. Anything else, Randy? Before
a bunch more. Robot is an object that is coded to respond to commands desired by the controller. It's an artificial organism programmed to do a specific task. A machine controlled by a computer that follows instructions. Technology that humans can code to make it do what they want it to do. It's like WALL-E. Yep. A machine to do automatic tasking can be reprogrammed. Someone says they don't need to tell kids what a robot is. They have their own ideas.
Great answer.
It's a type of automated machine that can execute specific tasks with little or no human intervention.
So as someone who has the opportunity to be able to interact with a lot of people who know about robots, working at Autodesk, one of my favorite things was walking around our office and asking people, like, is that coffee machine a robot? Is the dishwasher, is that a robot? So it's always fun to also think about, like, what are some things, objects in our lives that are robots that we may not realize that they are, and maybe even think about, like, what are some objects in our homes, for example, that could be adapted in some way to become robots. So all types of creativity is going to happen tonight, and thinking about what it means to be a robot, and also then how to spread the love of robots to your students. So again, welcome if you're just joining us. This is the Teaching with Tinkercad webinar. Our topic for tonight is introducing robotics with Tinkercad. I am one of the hosts tonight. My name is Kellyanne Mahoney. I'm a youth program specialist at Autodesk. I was a teacher actually in the Boston Public Schools for 13 years before I joined Autodesk. I wasn't a middle school English teacher, but I had a strong love of robots, even so. So I hope that you can, spread this interdisciplinary love of robots to your students too. We also are joined by Randy tonight. Randy, you want to say hi and introduce yourself?
Hi, I'm Randy. I am on the K-12 product team here at Autodesk. So I work primarily on Tinkercad and Instructables, and I have been with Autodesk a while, and I really like building robots. I think you'll actually learn about that a little bit later. Another thing I just want to mention, I see 2 people raise their hands. If you have a question, please ask in the Q&A section, and someone from staff will answer you.
Thank you, Randy. And there are other ways to connect with us as well, including in the chat, in the question and answer. We'll explain that again in a moment. But we are on Twitter and Instagram. Our handles are Tinkercad, @Instructables, @Autodesk EDU. We are also super cool that we have TikTok accounts now. I still haven't gotten over how cool that is. So the changes up a little bit for Tinkercad and @Instructables. We also use the hashtag Tinker Together. So if there's anything that you find inspiring tonight, and I'm sure you will from our speakers this evening, feel free to tweet at us or to send messages to us, hashtag Tinker Together. I did want to say that Randy not only is an amazing chat vocalist who's going to vocalize all your chats and be the champion of the chat tonight, he also is an expert on robotics, and he's created some awesome resources for all people, including teachers, on how to get started with robots. So there's a link that Randy is going to be sharing in the chat of a kind of basic beginners robots class that he wrote over Instructables a few years ago. Randy has also authored a book on homemade robots. And not only has he authored a book on homemade robots, he also authored an Instructable that will teach you how to turn your book into a robot using household objects that you can find, anywhere in your home. So we do have a subject matter expert in the chat. In addition to our amazing guests this evening, I'm so excited to welcome them. I know that you're going to learn so much from them, including Kevin Smith, who is the STEM program manager at Mass Robotics. He's going to talk to you a little bit about what Mass Robotics is and also his very cool role there, introducing young people to STEM. You can connect with Mass Robotics on Instagram and Twitter as well. We also are going to be joined this evening by our colleague, Christian Promick. He's going to talk a little bit about a new feature in the code blocks environment in Tinkercad. So that will be exciting, so stay tuned for that. And last but not least, we are joined by Donald McCoy, who is a K-to college STEM consultant and also a retired electrical engineer from IBM, where he worked for 30 years, starting out as an electrical engineer and then moving into roles to help young people and to think about how we can prepare future engineers and to provide them with workforce development. So excited to hear from Donald tonight. How to participate, Randy already began talking about that. You guys are already doing it. This chat again is your chat. We want this to be as much as a 2-way, 3-way, 307, 308 way conversation. So please keep it going in the chat. So again, if you want to connect with each other, please use the chat icon. But if you have like a specific question that you want answered by someone from the Autodesk team, or maybe even someone who's on the panel, please use the question and answer feature, because that's an easy way for us to be able to make sure that we're answering your questions. And there are real humans, they are not robots tonight, although Kevin does have some robots behind him, but there are real humans in the chat who are there to answer your questions throughout the webinar this evening. Our goals for this whole series are to integrate content from a variety of subject areas and grade levels into meaningful interdisciplinary design-based learning experiences. And tonight we're going to talk about how robots and robotics can be a vehicle for doing that and making interdisciplinary connections you may not have even necessarily realized. We also want for when students are being encouraged to create these awesome things like robots, we want to make sure that there's a way in for all students to be able to access them. And sometimes when we think about robotics, we think of it as this like very high level concept, but it's actually a really encourages a lot of hands-on activities and like different kind of ways of participating that makes robotics a super accessible way to introduce STEM to students. We also are going to be talking about emerging trends and thinking about the future of work and how to connect what you're teaching to awesome careers that your students might be interested in. And we at some point today might talk a little bit about more advanced skills in ways where you might want to move from Tinkercad to Fusion 360. Last but not least, our goal is for you to be able to ask questions to the Tinkercad team. So please do that, throughout this episode, and we'll also have a question and answer section at the end. This is the 4th webinar in our series. We are recording these, so do know that probably by tomorrow, if not by Monday, this will be up on YouTube on this playlist. We've already had 3 exciting episodes. And then we do have one more. So our series finale is on Thursday, May 25th. And our topic is going to be about culturally responsive maker spaces. So we're going to talk a little bit more about that at the end of tonight's episode. So our agenda for this evening. We will begin with Kevin, who is going to talk about what robots are made of. So sugar and spice and everything nice, and maybe some other things that he's going to talk about in between. Next, we're going to hear from Christian, who's going to talk about how, in thinking about computational thinking as kind of a central concept to teaching robotics to your students, how you might challenge them to think about how they could design things in a more efficient way using a new feature in code blocks. Next, we're going to hear from Donald, who's going to talk about how you can sort of integrate all of this into fun projects that you can teach with students, really kind of giving specific examples from Tinkercad and Instructables and projects that he's done with his students in North Carolina. And last but not least, we will have a question and answer session. Before we begin, though, Randy is going to give a poll just so that we can get a sense of where you're coming from and what kind of subjects you're teaching. So Randy just launched the poll, and the poll question is, what subjects do you primarily teach? So we're seeing a lot of computer science and coding, some art, design and 3D design seems to be pretty prominent as well. Some engineering. Oh, there's a lot of robotics teachers too.
A little bit of math.
A little bit of math. So we'll let this go for a few more seconds.
Don't forget about the language arts teachers.
And I love that the language arts teachers are here. I was an English teacher. I used to always participate in Hour of Code and talk about how, you can think about like the different parts of a sentence and how you can relate them to like, Sprite and, and thinking about when you're teaching Scratch. So exciting. So we're going to end the poll now. Share the results. And then we are going to, we're going to move on to Kevin's presentation. But before we do so, we keep saying, we kind of almost sound like robots saying Autodesk. And, what is Autodesk? So Autodesk, we are a software company. We empower innovators with design and make technology to achieve the new possible. One of the ways that we try to empower innovators is through a partnership that we have with First Robotics. And I just wanted to share, this was like kind of a cool video that our team shared out from the recent First Robotics Championship in Houston last week. So that's just a little tidbit about what Autodesk is, and you're going to learn more about what you can do with our tools in a moment. But I'm going to pass it over to Kevin, who's going to tell us about what robots are made of. So Kevin, feel free to take over the screen.
All right, perfect. I hope everyone is doing well today. So I feel like we got started with the perfect question about what is, how you would describe a robot. And I'll tell you why I say that's the perfect question in a couple of minutes. But first, let me introduce myself and Mass Robotics. So my name is Kevin Smith. I have the pleasure of running the STEM program at Mass Robotics. Who Mass Robotics is, what we do. Mass Robotics is an independent nonprofit organization created to enable the next generation of robotics and smart connected device companies worldwide. So we're we support the next generation of companies worldwide, and we do this through advocating, incubating, accelerating, and educating. And I have the pleasure of running the education department here at Mass Robotics. What does that really entail? Working with lots of robotics companies, getting to know technology that may not come out for 10 years, technology that I may not be able to talk about all the time, but being able to package those experiences into bite-sized pieces for teachers, for students, to be able to grow, to be able to develop the next generation of workforce within this realm. And as you see, these are a couple of my friends behind me. We're always surrounded by robotics here. Even the mural, the mosaic that you see behind me was actually built by a robot too. We're all about robots. But a little bit about me, I have my background in computer engineering from Boston University. And I had the pleasure of working with Boston Public Schools as not just an educator, but I also got to lead a team of educators teaching coding, robotics, and 3D design. So this realm that we're in is my playground, and this is where I love to live. So if I take things a little bit too far, or go deep with things, please just ask your questions in the chat, and then we'll clarify everything as we go, all right? So the reason why I said the initial question was perfect is because being here at Mass Robotics, I generally ask everyone, what is a robot? And I get a lot of interesting answers, as we saw a lot of interesting answers in the chat. But if I were to give a definition of what a robot is that does not include anything that is not a robot, I would make sure that that definition has 3 core components. What would it be? Robots sense, compute, and actuate. So what do I mean by this? So robots use some type of sensors to sense the world around them. It can be a touch sensor, it can be a camera, LiDAR, all type of different sensors taking in information, right? Once it takes in that information, it computes, it processes that information, and then it actuates. The root word being act, it has to do something with the processing that is done, right? So at a root place, this is what robots are, all robots are, and how they operate. But for today, I wanted to go one step deeper, not just ask what is a robot, but what are the fundamental components that a robot consists of? And this is a really interesting question, but you may already know the answer to this. So I would say that a robot consists of 3 simple things: hardware, the software, and the housing for the hardware and software. All right, so when I refer to hardware, I mean the processing boards, the PCBs, the electronic chips, but not just those, also the wires. When we were younger, we learned that keyboards and our mice were pieces of hardware, and they are. All of these things are pieces of hardware that can be incorporated. The second thing is the software. The software is what's moving all of the hardware. So if we look at the hardware as anything that's sending that electrical signal, those ones and zeros, those highs and lows, the software is what's processing all of that data so that we can make sense out of all this and get an actual product. But none of that is possible without the housing, because you have to protect all the hardware to ensure its integrity, to make sure that as someone's using the product, it creates that consistent output every time. It's no good if a child programs a robot, but it starts falling apart after every use, and they have to rebuild it. So housing is a definite another important piece. So understanding that hardware, software, and the housing are the 3 core components to constructing a robot. We're going to dive into Tinkercad and see how we can complete each of these 3 components all within the platform that we have in front of us, right? So how are we going to do this? A lot of people may be familiar with project-based learning. So I'm going to provide an example, a little challenge, and we're going to work through that challenge to see how we would incorporate all three different aspects into this one cool project. So first thing, what are we doing? The challenge is to create an instrument using Tinkercad. This sounds interesting, but I picked this for a reason, and we're going to see that really soon. I think you all might like the reason why I picked this. But the rules are that your instrument must use speakers to output the sound. So it's going to be an electronic instrument. And the instrument should be playable by a person. What do I mean by this? Meaning that once you provide a power source to your instrument, it should not just start playing itself. It should not just start outputting sound, because then it's not quite an instrument. It has to be playable by a person where when a person presses a note, a key, anything of that nature, it responds. And you could move forward with that. And the tools that we're going to be using to accomplish this are pretty basic: computer speakers, wires, Arduinos, or makey-makeys for the lower levels, buttons, paper. It can go on and on based off of the classroom that you're in. Okay. So this is the exciting part. This is the reason why I chose this as a project for you guys. I wanted to share this video.
There is no sound, Kevin, though.
Oh, no.
It's okay. I can sing too.
Can you hear the sound? So I'll explain what's going on. So what you see in front of you is a piano. So as the person playing the piano placed each wire inside of one of the cups, what they were doing was actually creating a circuit. They were creating a circuit, and upon adding the leaf into there, it actually plays a note.
So cool.
So it's able to create an actual piano, like pressing the different keys simply by using this device. So I have a kind of layout of what essentially was happening. There in the background, you saw a makey-makey, which is this kind of central device, and that makey-makey was connected to a computer. That computer is providing the processing power, is providing the voltage to power the entire system as well. And the first thing I want to point out to you is to the left of where it says makey-makey, there is a sideways triangle that kind of looks like it's coming to a point with 3 bars. What that is that's telling us that this circuit is grounded at this point. That's the symbol this side. Let us know what's grounded and what's not. And then if you look at the circle coming out of the makey-makey, you'll see an apple. That apple was essentially where the cups of water were. There were cups of water connected to a circuit. We saw them put one wire into the water. And then on the other end of the wire, instead of having a person there, we had a aloe vera plant connected to the other end of the wire. So when the aloe vera plant and the water touched each other, what that did is complete a circuit. It allowed electrons to flow freely through from one all the way throughout the wire. In this case, we can call that something like a button, right? So when the button is pressed down, it's the same thing as connecting these two components, the water and the plant, to make the sound. And that when we make that connection, we would like to say that that's a high signal or a 1 inside of our circuit, while when they're not touching, we say that no electrons are passing, or the signal we have at that point is at a 0. So what this is identifying, if we want to take a step back of what we kind of know from all of this, we know that communication is sent throughout the circuit using ones and zeros, highs and low signals, right? We understand that the circuit has to have a voltage source, has to have a power source, but it must also be grounded. And the last interesting thing is that if we try to put two of these quote unquote buttons in parallel and inside of the same loop, we'll notice that both of the buttons have to be down at the same time for the current to be, for the circuit to be closed and fully connected, unless we have our buttons in parallel, which essentially creates separate loops for each button. I'm not going to go into all the details of that, but what I will do is say that we have this overall challenge that we can break down into smaller bits, right? So the first thing, our first goal is to create a circuit that functions with the buttons in parallel, right? So if we can figure out how to make a parallel circuit, we're one step closer to where we need to get. The second thing we need to do is we need to discover how when we press one of the buttons, when we complete one of the circuits, that we're able to broadcast a sound, a signal. And then the third thing is going to incorporate all the knowledge from having this buttons in parallel and creating the sound to be able to generate our instrument. It sounds really difficult, but it actually breaks down to a couple of pretty simple things. All right, so what I want to do now is show you what does this look like in Tinkercad. So Tinkercad has a portion inside that is related to circuits. Has anybody familiar with the circuit aspect of Tinkercad? Is everybody familiar with the circuit aspect of Tinkercad? Perfect, perfect. So what I'm going to do now is go directly to Tinkercad. All right, so here is the example that I was showing. So inside of Tinkercad, you can do some really interesting things. So they have essentially an entire electronics lab. I'm not sure if anybody went to school for engineering, but I did. And when I was in my electronics lab, I destroyed so many LEDs, so many resistors, a little bit of everything. So having a place like this online saves not only so much headache, but a lot of money as well, and parts. So the first thing we needed to do is create a circuit in parallel, right? That executes everything we needed to do. And I did all that using all of these buttons, these features that we can find on the right side. The way I do that is by hitting the start button to start my project. And once I do that to demonstrate for everybody, if I hit each of these buttons, you'll notice that each of the lights lights up when I hit that button. However, if I toggle this right here, it's a photoresistor for those who are wondering. What's the difference between the light and I toggle that? Did you notice how they actually got brighter with this photoresistor turned up? I'm not going to go into this, but something to think about is if you were creating an instrument, how could something like this impact your instrument that you're creating? What aspect could that be speaking to? I'll leave that for you to think about. And the second part that we have to do is figure out how to make a sound using a button. So right here, you'll see that it looks a little bit more is going on. We have a speaker right here, and this weird yellow box is actually measuring the voltage passing through our. So if I press the button, you'll notice that while the button is pressed down, that this item, the meter actually reads a little bit higher. And It reads at 330 because if you come down here, that's actually the amount of voltage being given fed directly to our system. Okay, so after we are able to play with our circuits to be able to get our button to make a sound just like this, the last and final step is combining all of the ideas, right? So this is where we're able to clean it up a little bit more in Tinkercad. You'll notice that in Tinkercad, you're able to change the wire colors to be able to follow exactly where the voltage is flowing. And then here I'm able to show that using yellow that all of the wires connected to this button, you can track using yellow, and you can see where everything is rounded easy. So it's a tool that makes things a little bit easier to follow as a teacher. But the cool part about this is that yes, we get all of this to function, but we didn't have to try it out on the physical device. We were able to do all of this in Tinkercad. The way that we did that is up here near where we started the simulation in the right corner. If you click on the word code, it actually allows you to generate code within Tinkercad, allowing you to access the actual both Arduinos that I have set up, as well as a lot of different inputs within the system. This is really cool because it takes both digital and analog outputs, and as well as it's able to interact with a varying amount of sensors through those ports as well. I personally think the ability to use the blocks and text is really, really cool because as the students, if they're more comfortable with the blocks, are able to write out their entire codes, deliver a function, they can see in real time C++ how that translates over and can become more comfortable with the syntax of it. I know this is a lot, so I'm going to hop back over here. So far what we've done is we've had a look at the hardware and how we can develop a lot of electronic modeling within Tinkercad without breaking a lot of tools. And the second thing is we had the opportunity to be able to create our code, to program an Arduino, all within Tinkercad to be able to do some really, really cool functioning. And from that, you can easily upload it to a physical device. You can recreate this circuit in real life and be able to move forward. And it's amazing. And so we have the hardware, we have the software. And the last component is the housing. So this is where most people may have gotten introduced to Tinkercad with the 3D kind of workspace where you can really 3D design a lot of different things. This is an example of to the right are in red and blue are really, really basic housings that will house the breadboard in the larger square area, and then the smaller square area house the Arduino. You'll notice that there are circles, cylinders placed in very strategic points so that you could have screws to be able to lock in the Arduinos and make sure that that's a nice snug fit if you like. And another way that you could create the housing, a little bit more fun direction, is if you took what you generated and printed out let's say a trumpet, because we have 3 buttons. There are actually buttons that are a little bit longer than the buttons that I have inside of the demo that you can place through the hollow tube of the trumpet, and by placing it in the vertical tube, you can create a functional trumpet while including a flat platform at the bottom to house your Arduino, your breadboards, and all the other wires that go along with it. So with something like this, your students can create and learn all about electronics, understand the coding, the CS behind programming Arduino, but still understand the design aspect of 3D design and all the complexities that go with that. Creating a very holistic experience that you as a teacher can really take in so many directions based off of what your class needs are and the projects that you have available to you. So overall, is this challenging? Is all of this that I'm speaking about a challenge? Yes. It's not something that will necessarily you'll step into and be perfect the first time. But what I want to point out is a quote that a Boston public school educator who visited Mass Robotics said earlier this year. He said that he wanted to echo his coworkers' thanks and to point out that not only did he learn more about robotics, but he saw students do independent programming that he had not seen them do before. And it was tremendously encouraging to him. So I'm saying all of this because I challenge you to raise the bar for yourself and your technical expertise. I challenge you to raise the bar for your students so that they can achieve new heights. And most of all, I challenge each of you to fail forward, meaning we do not have to be perfect at everything we do. In robotics, nobody programs everything right the first time. But if we, through our quote unquote failure, if we're able to learn something, if we're able to continue moving forward, everything comes together and we're able to make a huge difference. All right. So before I leave you, I just wanted to share a couple of things with you all. September 29th, I'm sorry, I got to edit this slide. September 29th, September 30th, for anyone who's around the Boston area, we will be hosting a Robo block party where in the Seaport Commons, where over 40 companies and universities are coming out to showcase robotics and technology. So if you'd like any information about this, or on the right, we also host Drone Academy as well as Underwater Drone Academy. Both of those are happening this summer as well. We do some really cool stuff here. Feel free to reach out to me about any questions, anything that you have, but I don't want to hold up too much more. So I'm going to stop sharing.
That's what robots are made of. And you've just brought me back to thinking about how much fun the robot block party is. As much fun as this webinar is right now. I would love to go to the robot block party too. but this is a fun question, I thought. So Kevin got my wheels spinning and thinking about just also like different combinations. Like when we think about the different parts of a robot, there's sensors are involved, there's actuators or motors. What are some cool combinations that you can think of? It could be a useful idea or it could be a silly idea. We have some silly examples at the bottom. So we have a servo kind of like waving to always have someone saying hi and welcoming you. We have a telepresence robot, maybe kind of more of a useful innovation might be curtains that open automatically for you because there's like a light sensor on them so that they know when it's time to open the curtains. Randy, do you have any ideas or do you see any fun ideas in the chat of different fun combinations of sensors and actuators?
None in the chat yet, but there's always a ton of things. It's like
I'm sure your mind is brewing with them, Randy. Yeah. Come at us with them.
I've been wanting to make solar tracking, solar panel tracking that follows the sun. So that's something that's sort of been on my to-do list in terms of actuators. Mm-hmm. Let's see, what else? Stop to turn on lights. That's always fun. Mm-hmm. A robot that kicks a ball into a goal. Moisture sensor for a garden. Yeah, I've made automatic plant watering systems. Those are fun. Mm-hmm. Pond monitor. Everyone seems gardening on the mind right now.
I'm seeing the alcohol sensor one and it's making me laugh and think of like funny things that could do as well.
Oh yeah, I've seen lots of alcohol sensing projects. The best ones are ones that stop people, not encourage them to go on.
Yes, 100%. All right, so keep sharing your silly and useful ideas in the chat, and we are going to move on to our next segment, in which Christian's going to come on and tell us to tidy up our code blocks. Christian, the screen is yours. Take it away.
All right. Can you hear me okay?
I can.
All right, let me share my screen. And I'm going to jump right into code blocks here. Can I do this? Here we go. Do you see my dashboard now?
Yep.
Oh, good. Okay, here's my dashboard. So I wanted to share a new feature that we just released in code blocks. If you have not heard of code blocks, we have a code blocks editor on your dashboard down here just below 3D designs and circuits designs. There's code blocks. You saw code blocks in Kevin's presentation, and that was taking place in the circuits editor. Those were code blocks like scratch blocks that he used to program the behaviors of a microcontroller within the circuits editor. Well, we have a dedicated code blocks editor. So let me create a new one, and I'm going to show you some new things we just released. You may not have seen it yet. What I'm going to show you is if you scroll down to the bottom of the library of code blocks, we have this new thing called templates. So this is replacing some of these other purple legacy blocks that we have down here. These are basically not necessary or needed anymore now that we have templates. So what does a template do? Let's create one. I'll call this a gem. So I'm going to make like an array of gems that are all unique. Okay. So let's go ahead and just create one. So that's the beauty of a template, is you create one and then you can instantiate it. Very much like a define function and then an instantiating that function to create the actual object. Before, if you created an object, it actually put it there, even if you didn't need it yet. So let's go ahead and create this thing. I've been using this example. I'll put a cone in here. Okay, so I'm going to define my template just as this cone. Now watch what happens. When I play this, I'll get a cone, right? Let's see if I can click it. Let's see. I might need to refresh here. I'm having trouble connecting to clicking on the actual interface with this Zoom thing. Let's see if this works now. Here we go. Okay, so here's my cone. So what I can do, if I didn't have this create from template thing and I played it, I would not get the cone. Okay, so my template is just defined, but not brought into the scene. So if I scroll down here, I can add this create from template, and this is what actually creates the object. Okay, so this is defining it and this is creating it. So let's make some changes to this gem here. I don't want a small top. I want to, let's do some random stuff. So I'm going to drop these random green blocks right in here. And I want to say the top radius is going to be between 8 and let's say 15. I'm just going to do a bunch of random stuff here. I want the bottom radius to be between 0 and 5. I want the height to be random between, what do I want it to be? 15 and 22. And then the sides, this is what kind of makes it look gem-like, is I'll put between 3 and let's just say 12. Now watch what happens when I play this. I get this, and it's based off of my template here. So it's really just creating that object when I put it here. But if I keep playing this, it's going to be different every time. See that? Kind of cool. So I've defined this one template with this single cone block with a bunch of random stuff built into it. And when I play it, I get a different result. Great. Well, let's take that a little bit further. I want to create an array of different colored blocks. So one thing we've also just added in addition to the templates is if you scroll to these purple blocks here, you can see there's setting a color. So I could, do the same here. And when I create this, just put set the color to something, here's hue, saturation, value. I'll say I want to have like, if I want bluish blocks, I can say 200 to 255 for my hue. So now every time I play it, I'm getting like kind of a blue. Oh, I need these to be 100. Let's see, let's do that. So now I should get a blue. So I'm getting a different blue every time. Okay, so I take that a little farther, and I did the like baking show thing, and I have it pre-cooked. But here it is. Here's my gem. Let me close this one because I can see that I'm having some graphic stuff with all of this Zoom business. So let me play this one now. What this does basically is it creates my gem, my random gem, and it's going to put it. I put it the create from template thing here in a repeat loop. So it's going to create 10 of these, and it's going to move them down the x-axis, so they're arrayed. And then what it's going to do is do that 10 times, moving it in y. So I'll have a grid of 10 by 10 gems, and why don't I just play it? It's probably better to look at it. So you can see my one template that I've defined with some randomness and some color randomness as well, and moving it with my variables here that I've created, incrementing my variables as it loops through so that they don't all overlap. I've created a random grid of 100 different unique gems here with my code blocks. So I can play this again and it'll be completely different here this time. And so I can go in. The nice thing about code blocks is you can create chunks of code that you can come back and reuse. You don't have to go in and manually model it every time you need something. The nice thing is you can come in and say, well, I want to have, you know, certain types of geometry, or in this case, maybe I can just set the color to be that blue that I liked. For example, let's go to 190 to 255. And you'll see I'll get various blues here. So I just changed a couple parameters there and I got a completely different set of looking things. Great. So that's kind of the template and really kind of showing you what that's all about. Let me go to an even more practical example, maybe related to robotics, gears, right? How do robots move? Gears. So I just searched here gear generator, and I filtered by code blocks. And I'm gonna copy and tinker this one. This is, I'm giving credit to Marabi 10_C1815. Thank you, sir, for your circuit. I'm going to use that. Now he or she used the old antiquated create new object stuff. So I just took his code blocks. I copied and tinkered his from my gallery search and moved his into the template stuff. So you can see I have a template for this tooth of the gear to define a tooth and a template to define the gear. Okay, and I'm going to refresh this real quick just to make sure I have the resources I need here. And let's just see what this does. So what it's going to do is, well, I'll just show you basically the layout here. I have my variables defined here. So this gear was set up with variables where you can come in here and, like I did with the blueness of my gems, I can come in and edit these parameters and get a very different looking gear. Okay, so I'll show that in a sec. This defines my tooth. I don't put the tooth in there yet, but, and this, I don't know where he came from. I'm going to get rid of that. The gear here then instantiates the tooth within it when it goes and uses a loop to array it around the cylinder. Okay. And here if this weren't there, then my gear won't generate. So let's just see what happens. I'm going to put this on fast forward mode and go ahead and play it. And I'm going to dismiss that Outlook thing. Okay, so my teeth are coming in here and it groups it and gives it a color, and you can see I have my gear. Great. So this would have taken some time. It took some time to lay out the code and do all the math. But my variables are set up so that when it runs through the code blocks, we're doing some of the math operators in here to make sure that everything lines up and ends up with a result that you're looking for. So let's change this a little bit. Let's do less teeth. Let's do like 15 teeth, thickness of, let's do outer diameter of, let's go up to 45, let's say. I don't know. Let's go down. Let's go down to 15. Tooth thickness can go down to 2. The tooth length will bump it up to 4. Also, check it out. These are at a slight angle. I can really accentuate that by hitting it, bumping that up to 45. So now let's watch what happens. So now my gear generator, just by adjusting some of these parameters, my gear looks totally different, right? You see that? So you can find this as well yourself on the gallery, very similar to what I did. You can just go into the gallery. Where am I here? Somewhere over here. There it is. You can just go in and click this little magnifying glass and find projects like this that you may, chunks of code that you might want to reuse in your project. So I think that's it. That's all I wanted to show here. Check out code blocks. The actual, where am I? There I am. Here. Check out code blocks. We are actively working on it, and there's some really cool stuff that's coming. And we'll have more stories for you on this editor in the future. So thanks for listening, and back to you, Kellyanne.
Thank you, Christian. And also just thinking about like, even just the idea of like parametric modeling and how that, you know, when you're thinking about even like designing like the casings for a robot or even some of the components of a robot, if you're, you know, combining like bespoke parts with, you know, your kit of parts, just being able to make those kind of quick and easy adjustments and that kind of flexibility. It's not just, you know, building students computational thinking, but it's also, you know, helping them think about how they can expand their kind of design skills in CAD as well. So one of the things we were thinking about is, you know, is there an example? So Christian showed us gems, he showed us gears. Is there another example that you could think of a template that maybe you might share out to students that they might, you know, customize, they might want to customize in their own way, or maybe there's like a use case for wanting to customize it?
We have levers, that's a good one. Spinning top. Baskets, snowflakes, name tags, a beam generator. Yeah, that's great for building.
Oh, a beam generator within the context of building. That's interesting.
Yeah, a Vex beam generator.
Okay.
Chains and gears, yeah, that's another one. And pulleys would be another great one. Housing specifics for boards, like an Arduino one. Oh, it's moving fast now. Little parts of the house, fonts, housing.
Wow. All right, we'll keep sharing ideas with one another. This chat, again, this chat is your chat. I feel like I could come up with a song about it, but I want to keep us moving because I do believe that Donald is going to help us come full circle in thinking about now, how are we going to pull all this together? There's a lot of information that we've brought to you during this webinar, and Donald is going to take it away and talk to us about how we can piece this all together and assemble it into something that we can share with students.
Thank you, Kellyanne.
Feel free to steal the screen, Donald.
Okay, here we go. So good afternoon, good evening, wherever you are around the world. I just love writing down here a moment ago from the different places that we are represented today. So what we want to do in the next few minutes is really consider Tinkercad and teaching robotics as one. So if we flip through this, whatever we're going to do should start with the engineering design process. These 5 steps really pulls it together. It doesn't matter if it's this most complex technological device or the most simple. We have to start with asking, what problem are we trying to solve? Given the imagination and the brainstorming, the planning, and step 3, that's really where Tinkercad comes to play, because that's what Kevin was telling you. No longer did he have to blow up devices. He could actually see faults within the Tinkercad application, and obviously create in both the virtual as well as the physical world. and then constantly improving. That's what engineers do. So one of the things we want to introduce to you is giving your students a research assignment. So I'm using Google here. Just using the search parameters of Tinkercad plus robotics, you get a whole plethora of activities. I mean, hundreds of them. This little slide here just shows a snapshot. So what I'm going to do for you now is just bring it together by selecting one. It pops out to be a factory robot arm. So this actual rendering here is actually in Tinkercad. I've given you the link there that you can go out, and there are many of them variations. Now you need to control that, right? So here is an Arduino-based controller with motors and all, using 4 servo motors here with an external power supply. Phenomenal opportunities. Again, I've given you the link, but there are many out there. Next is the code. You need to control the arm, right? So the Arduino code is out there. Now, both Kevin as well as Christian have shown you block code, but we can also do it in C++. So one of the next things I want you to think about really hard is consider both Tinkercad and robotics as tools. As you can see, just the definition of tools itself is to carry out a particular function. Let's do that. Again, if you do a Google search, just say Tinkercad, Arduino, plus robot, plus ARM, you will see that one along with many others that you can actually perform, but also you will see some other applications that you can use, like this one that's by the Arduino company. I'm not advocating it. I'm just saying it's there, but also they give you the CAD files and control systems that's used in there, all of the circuits. I was just amazed. Now, let me shift gears for you. As Kellyanne mentioned earlier, I'm retired, so I did my 30 years at the IBM Corporation in a wide variety of jobs. But one of the things I take from those is going into university. So here is one of the projects that I work with North Carolina A&T State University in Greensboro, North Carolina. Now, this is an eye test, but in the year 2008, the National Academy of Engineers defined 14 grand challenges that says our world really need to get our act together across these 6 spaces here, from better healthcare, which was very dominant during the pandemic timeframe. Obviously, energy, water, access to clean water, that's a big deal around the world, as you well know. And you can see the other ones. I've given you the link there so you can take a deeper dive. But what I want to focus on here and how Autodesk and the Tinkercad community is really helping us is in that category of education and delivery. Just think about it. Why corporations will make applications like this free? It's to promote the brand. It's to promote the industry of STEM and the whole notion behind that. So advanced personalized learning, which we saw a lot of during the pandemic, as well as now, and it's part of our life, right? For those who are really engaged in professional development, tools that really help us to enable scientific discovery is at the foundation of a lot of things. So I encourage you to go out and take a look at the engineering grand challenges. These are global that represent here. So I'm going to give us a snapshot of how all of this comes together using the Tinkercad community of resources from the gallery, the projects and Instructable's website and the like. So let me take you down that path real quick. Now, Christian gave you a snapshot of this a moment ago. This search engine that Tinkercad and the Autodesk Corporation has put together here is very robust. So let me just give you a snapshot of it. So here under this bracket, you have the tinkering areas from the circuits, from the 3D design, code blocks and all those you will find. But then you have the gallery under here. You have various project classrooms that you can create and a whole host of resources that the Tinkercad team has created for you. Step 2 here, now you can say, what type of design am I looking for? From the 3D design, circuits, code blocks that Kristen just showed you a moment ago, as well as people. You remember a moment ago, Chris gave a shout out to someone who had real, provided a good segue into a design that he was working on by looking up that person by name. Here is what I did for this project here. I put in some keywords of robots, robotics, sensors, motors. You can see all of them down there. I got a wide variety of input. And now I can refine that even further with their rich search tool here into relevance, trending, likes, and things of that nature, as well as the filtering. But you can take yourself very deep into the dive and immerse yourself with that. So let's talk about some of these type of things that's using a robot. Now, this comes directly out of the Arduino starter kits, and I'm going to show you a little bit about that later, but I just want to give you a snapshot of what it is. So every robot that has the design parameters to know its environment uses some type of sensing device, be it ultrasonic, be it temperature, be it other types of sensors that would provide it touch. I mean, it's a whole plethora of those. So using this one here, you can actually see the distance. As you can see here, it's actually giving you the distance at 44.7 inches or 113.4 centimeters. But this is the key. They give you the free code right there that you can start with and then begin operating immediately. And what I want you to show you next, still using this same platform, now what you're able to do is go from the virtual over to the physical using the instructables. I found this out there just by doing a search. So now you probably see that ultrasonic sensor sitting on the front of that robot. So now you can use it as an avoiding robot feature that provides a lot of autonomy to that robot or automation to it. And you have the links there. So I wanted to make sure that you can take advantage of those. Now, you saw earlier, the robots have a lot of motors. Here's an example of an Arduino starter kit that provides the code for a servo motor. I've highlighted just a couple of these because you can see that green wire actually goes over to pin 9, as you can see there in line 6 of the code. And what is this robot going to do, right? They give you the comments there to tell you it's going to sweep from 0 to 180 degrees in 1 degree increments. And then line 12, it takes it into a for loop, right? So it's going to do that all the way until it gets to the end. Then I didn't give you the rest of the code. This is just a snapshot. But if you go out there, and we're going to show you later, the full code is there. It's so rich. Now, again, using that same format, taking it from the virtual over to the physical, again, using instructables. This was a really cool laser fighting robot that provides a rich opportunity for you to engage a joystick as well as 2 of those servos together. Wonderful technique, wonderful. Line following robots. They are all over the place, right? That's one of the first applications many students get accustomed to. Again, came directly off of instructables. I just did that search. And also, there's a circuit there. And I have down there in the little caption, there are many variations of these light sensing circuits using a wide variety of circuitry to control motors. I won't go into a lot of it here, but this is just one of the great ones that I found right away. Now, how do you take this to the next level? That robot on the right here, the physical build one, you can actually replicate that in Tinkercad. Again, using the search features, I just found that. I didn't create that, but I have the capability to remix and repurpose that. Next is, for those of you who are familiar with the Lego Mindstorm series, I was surprised to find that they actually have some people who have actually repurposed the, or redesigned, if I should say, or recreated the actual EV3 model there. And you see that little green display up there. They actually have LCD displays inside the Tinkercad starter kits that you can actually use to get that going. So you can actually create this, redimension it, the physical aspects of it as you like. Again, free resources through instructables just by being effective in our searching. So let's take a moment and talk about the project-based learning, the experiential learning, and contextual learning, and all these rich resources that we have. And the one from my engineering background is, how do you reverse engineer something and make it more relevant to what you have in mind using that engineering design process? So sometimes you have to take your students from the fundamentals. So using a lemon battery or potato to generate electricity, to control DC motors, that comes directly out of Tinkercad. and then making it contextual with something that students are familiar with, traffic lights, right? How do you control lights, 3 of them? But what if you want to put it on steroids? And this comes directly out of the Tinkercad starter kits. Now you have, I think there's 8 of those they're using there, but because there are 13 ports of DODI, digital input, digital outputs on that Arduino, you can actually even increase more. I've given you some starter code that you can actually modify there. Again, this is directly out of Tinkercad resources. So let's sort of wrap this up and talk about our experiences. And I put them into 3 key areas here because one of the things I do a lot with is advanced manufacturing, teaching middle and high school students. And using this reverse engineering process is using robotics and having students understand all of the components there, from the wheels, the motors, the platform that was based on the one that you saw earlier, but have them reverse engineer that component to component, building it up. But also the communications and the soft skills are so important. So having them driving this reverse engineering model using the engineering design process, using all the tools out there, a lot of rich resources there, and then creating it so that they can actually work in a team, because Tinkercad has all these collaboration capabilities, which provides that, which is so rich across the platform, from 3D design side and obviously circuits and coding, so rich. Now, what I've provided here for you is taking an expanse of one of those robots that we've been using as our theme for the most part. Every star here, there is actually the Tinkercad circuit or 3D design component that can come directly out of there. And even some of the ones that's not, like the line tracking module, you may not have the actual module, but you have the light sensors that you can use to create that. But again, you can 3D print that. So now, one of the things I'm most proud of in my retirement is that I'm working with not only North Carolina A&T State University, but also North Carolina State University. Sometimes it gets tricky because I may have the apparel of one school and I'll forget that I'm at the other school, and they don't take kindly for that. At least they like harassing me. They say I'm old and can't remember where I am. Anyway, make a long story short, this is a great grant we won. This is actually $1.4 million to teach middle school students advanced manufacturing. Hey guys, you have the capability to do this. I'm working with 2, how do you call them, awesome teachers that I'm actually teaching them advanced manufacturing concepts. One is a history teacher, and the other came from CTE, well, careers in technical education, as a computer science area of that. And keyboarding, not even, not the electrical side of that, but basic fundamentals of keyboarding and computer systems, if you will. But here's the point I want you to take away. Those grant opportunities out there, I've given you the details here. Be more than happy to give you some information around it, because there are a lot of grant opportunities. So let me tell you one of the projects that we've done. Each year, the students have to do, as part of the grant, a student showcase. Within the showcase this year, we just actually did it about 2 weeks ago. They looked at manufacturing in 3 categories: pharmaceuticals, the energy or electronic systems, and food. So obviously contamination and airborne particles and things like that are very critical in each of those entities. So we found this this lesson plan online and purchased the parts. The software did not work, so we had to re-engineer it and get it working, which was a real challenge for the students. And as you can see here, we can actually measure the cleanness of the air in parts per million and the like. And you can see that LEDs would display the different ones. So we immerse the students in it. This is advanced manufacturing additive, right? So they designed their container, just like Kevin was talking about. Enclosure is a big piece of robotics. So that was done there using a 3D design module. We created it here to mount it, the product here inside the board using Arduino, simulated everything online. This is them in their actual showcase. The marker that you see in the right side of the display here is actually getting the gases that's coming out of that, the VOCs. It's phenomenal. I can't thank you enough for the opportunity to be with you today. And this was the closing shot of one of our great students doing a wonderful job in the at the showcase. And any questions, let me know. And I went fast. You know, I'm from North Carolina. That's what we do. We talk fast. And however, the main thing is you got all the slides, you got all the talking points here. And more importantly, you can put stemfirst@gmail.com and you can contact me. Thank you, Kellyanne and everybody.
Thank you so much, Donald. It's so funny whenever I hear you say that you've retired. I have a friend who's similarly, I think, minded of similar energy and enthusiasm who's retired, and she says she's rewired. She hasn't retired, she's rewired. And I think that works for you as like a good pun as well, right?
I like it. Mine is I have flunked retirement. In the retirement, I started teaching. And it was not in my plan, by the way. The phone just started ringing.
Well, your enthusiasm is infectious, and I can see why people keep calling you. Thank you so much, Donald. We're glad that we called you too. What's something, so there's many things, like my mind is like buzzing with all types of new ideas. What's something new you might try out in response to this webinar? So please let us know in the chat. So what's something new? It could just be like, you know, I'm going to let myself, you know, fail more in class in order to learn something new. Anything else in the chat, Randy?
Not yet. Nothing new. Reverse engineer a robot.
Reverse engineering is fun too.
Yeah. They're going to share this with their team for planning for next year.
We've had a lot of requests for the slides too. So just to say out loud too, the slides will be emailed to you. I believe it's on Monday. You get the email, but you know, do please reach out to us if you need them. Other things, Randy?
Yeah, they're going to try to use circuits to introduce Arduino, which is great. So a very low cost, easy way to do it. Let's see. Well, yes, lots of coding with Arduino. Might try block code templates with students. Create prosthetics and 3D anatomy. Oh, that's cool. Do a module in Rube Goldberg machines. I will mention if you plan to do that, you should check out Tinkercad SimLab, which
SimLab. Definitely.
If you weren't here last week, you should go check it out this week. Let's see. Lots of new things. Yeah, just lots of new things. Microbit as applied in Tinkercad.
Keep them flowing in the chat. We do want to make sure that we have some time for question and answer. Before we do that, we wanted to just share some announcements with you. So if you have not had enough webinars today or this week, there will be more. We will be hosting more free webinars for educators. So this is a different kind of webinar series. Well, it's actually it's a series of the same webinar at convenient times for you. And this is all about Fusion 360. So if that's something that you're curious about, we have links to attend May 8th. Another one is May 11th. So Randy will push out the links for that. So thinking about extending your learning from Tinkercad into Fusion 360. We also have an awesome contest, a project-based learning contest where you can win prizes for planning awesome lessons. And we're going to be offering over $40,000 in prizes. And you do have some time after school ends to maybe this is like a nice time to reflect after the year is over and to think about what your best lesson was that you taught and to share it as an instructable. Yes.
Yeah, I will also add there's lots of judges' prizes in lots of categories. So you should check it out because one of your specializations may be a judge's prize category. And so there's lots of chances to win there.
Yes, I was blown away by the variety of categories. There was architecture, there was art, there was all types of different categories. So pretty awesome. And then for students, we even have a webinar for students. So on May 4th, next week, I will actually be co-hosting a webinar in collaboration with the ACE Mentor program And our winner from the last year was Make It Modular, which is part of our Make It Real program, Michael Hidalgo, who created this awesome concept for affordable housing in his hometown of Miami, Florida. And he's going to be talking to students about his strategy for winning. So he won by creating an awesome CAD model. He also created a physical prototype of his model. And he also wrote an instructable that was very thoughtful about describing his process throughout. So he's going to share that with students. And that's going to be next week, May 4th. Students do not need to be part of the ACE program to join. And also our colleague Brandon Kramer just announced that he's going to be joining us for that too. And he was actually the one who helped one of our customers design this bridge that you see here that is kind of the central concept of the contest. So please spread the word to your students. And this is also all about the Make It Bridge contest. So we're going to be offering over $50,000 in scholarship prizes to students to do this again this year. So we partnered up with James Devlin, formerly of the New England Patriots, Connor Clifton, currently of the Boston Bruins. Both had studied engineering in college before joining professional sports, and they are out there trying to inspire students, particularly the next generation of students who are interested in architecture, engineering, and construction. So there's more information there that you can send to your students. The contest deadline for this one is June 26th. Our next webinar, so season finale, was going to be a really good one. So Thursday, May 25th, we're going to be talking about the topic of culturally responsive makerspaces. We're going to be joined by Jen Lee Reeves, who's the executive director and co-founder of Design With Us, and Kevin Butler, who is the Ubuntu Center coordinator and is also a Hidden Genius Project alum. The Ubuntu Center is part of the Hidden Genius kind of network. Both of these organizations showcase talents that this world is missing and thinking about how they can nurture young people with these talents to be able to grow and share their talents with the world. And we're going to be talking about how you, even just kind of thinking about moving into the summer and summer programming, you know, how can you think about some of those maker spaces, either at your school or in your community, how they can be more welcoming to all learners. So last but not least, we do have this poll, another poll tonight. Randy is getting ready to get it set up. So please let us know, how likely are you to use something that you learned in today's webinar? We're seeing a lot of very likelies and likelies. And this is a very niche-y topic, but we hope that, you know, by listening to our speakers tonight, you realize that there are many ways that many subjects at all grade levels can participate in robotics, and just how fun robotics is too as a concept. So looks like most of you all got something very meaningful out of this, and we're glad that you did, and we're glad that you joined us. And then just, you know that these slides will be shared with you probably on Monday. And, you know, it includes links here for different ways to connect with us. We also will be, for those of you who joined live this evening, we will be sharing with you this certificate. We wish we could give you the world, but right now we can at least help you document your professional development towards your professional development points, or any way that your district is able to give you credit for showing up here, as they should. So that's all we have for the formal program, but we also thank you for sticking around. We went a little over, as always. It's kind of our thing, but it's because we love what we do. So right now we're just going to stick around. We're in Brady Bunch mode at this point to see if you have any questions for us that you want answered live. Randy, any questions in the question and answer, or like those of you who are answering questions throughout the webinar, was there anything that it's like you answered it for one person, but it's like, I bet someone else had the same question?
Someone's asking, what's the point of connecting Fusion to Tinkercad? I guess I'll answer that one. Tinkercad's an advanced manufacturing tool, and not Fusion is an advanced manufacturing tool. I got that backwards. Tinkercad is a good place to begin learning and start understanding basically 3D literacy and concepts. When you're ready to move to 3D printing or having parts made or manufacturing, or just want to take your designs to the next level, that's when you might think about starting to move to Fusion. Okay. How does students sign up for the Bridge webinar? I can share that link back out.
Yep, just the link. Yep.
Let's see, what else do we have here? Someone's asking what your favorite 3D printer for the classroom is.
We at Autodesk love all 3D printers equally. I'm not sure if any of our guests do have any recommendations around 3D printers that they like.
All 3D printers are great. Let's ask another question. Is there any plan to code in our Arduino, make 3D model and then animate it based on servos? All right. So basically, is there any plan to move sort of the electronics into the 3D space or anything like that?
I can answer that. I think our goal, definitely our long-term goal, is to kind of better integrate all of the editors. So even the code blocks with the 3D and the circuits. That's like, definitely our end goal is to have a really nice sort of workflow amongst all of them. So the answer is like yes, and we'll get there eventually.
Let's see. Can I print items snap to Lego receptive tops? Short answer is yes. Yes, you can. Just have to design them.
Yeah, well, I've done that before, actually. Every printer prints a little differently, so you always kind of have to fine tune. That's a good place where the code blocks might come into play, where if you build like a Lego snappable thing, you might want to try a little template like I showed and print it and see how it works and make adjustments from there, because every printer will print differently. Once you lock in how yours are working, you can sort of save that code and reuse it. That's how I would do it.
All right, so we have two more here. One's for you, Kellyanne. Can Tinkercad think of programs that could be applied to civil engineering and architecture high school students?
Well, I mean, check out the Make It Bridge competition. Also, if you go to autodesk.com/makeitreal, we have all types of resources that particularly we did a series with James Devlin probably like 2 years ago, I think 2 or 3 years ago, where we actually walked students step by step from architecture into engineering and then ended in construction with different experts from Autodesk along the way. We also have a partnership with the ACE Mentor program, as we talked about. So that's a really great resource for students to be able to get mentoring. And ACE is just the United States in Canada. Another one that I saw recently, and I wish I had the link ready, but I thought it was absolutely brilliant, is someone made an HVAC set of blocks in Tinkercad that I thought was super cool. And that's a job that is really, I know particularly in Boston and in the construction industry, those that can use Revit in order to design HVAC systems or use the MEP side of Revit, that's like a really lucrative career. And it's also like for young people that like puzzling through things and maybe even like playing like, with puzzles and with games and video games. It's kind of, there's a lot of analogies between them and a lot of kind of satisfaction in that.
Okay. Cool. Are there any licensing concerns when copying a design from the gallery?
Yeah, if you click on something you find in the gallery, and I'm just going to do it live, even though you can't see that what I'm doing, you'll see there's a license on the design detail page down on the right hand side. There's most of them are Creative Commons licenses, but you can check what type of license it is when you do your search in the gallery and click on that small card. You get a bigger card that tells you that. Here's a question. Can we convert block coding into Python? And I'll give just sort of a short answer. You saw that in some of the examples that were presented, that some of the block codes translate and builds the C++ code automatically, right? If you use the microbit microcontroller in the circuits editor, so that it's not the Arduino, but the microbit, that will also do the same thing, but give you the Python code. So that's an option to use the Python.
All right.
Python method.
We have a question here about, will each student need an account? And that's basically, if you sign up as a teacher, you'll be able to easily onboard all of your students into their own accounts. It's a very easy and it's a very simple process. So even though they will need their own accounts, it's very easy to do. Let's see, what else do we have here? Kellyanne, you first mentioned that you guys worked with First Lego League. Can you speak more about what we used? About how you, rather, can you speak more about how you work with First Lego League? Sorry, I misread that question.
It was FRC that we were at last week. I know that there's many different ways that Autodesk works with First, in particularly at like a local level. For example, a lot of Autodesk employees are very involved in coaching teams and mentoring teams, and then kind of in a broader way, just in the ways that we provide, Fusion 360 and like other, tools that students can use. But I do think that there's a lot of energy and synergy that is continuing to grow between the way that we work with First. Does anybody else know anything about like with the younger ones, the little ones with Lego League?
I do. I've been a judge for First since 2006 during my IBM days, and I was a world judge for FLL. And even today, earlier this month, I was judging FRC for the chairman's. No, correction, I didn't do the chairman's this year. I did the Dean's List awards this year. And then for the FLL, oh, goodness gracious. I did so many, from robot design to performance, a whole bunch of it. There is, my mind is racing with so many components here. It is a wonderful organization. One that I have not done a lot with is FTC, because that's also at the high school level.
Yep.
And it's nice to see the Autodesk logo there at the world level. And I do mine here at the state level of North Carolina. We do a regional, we do a district, and then the state level.
It was really cool actually to keep talking about the Make It Modular contest from last year, but one of the winners from the contest last year, one of the students was a First student, and I think he was also in Florida as well. And he thought about the problem of because he helps coach, he does First, but then he helps coach the little ones with the Lego League. And he was talking about the problem of all the materials and where to store them and where to put them. So his design was actually like a outdoor kind of modular classroom in a shipping container, in which he like designed all of like the, like where everything would be stored and, what would be the best use of space. So it's a lot of overlap between our communities, not just with our teachers, but also kind of in what students are doing as well. It was super interesting to see.
Yeah, and I'll make this quick. I have seen people 3D print their storage locations, like a grid, where they can put their very sized items. And I use fishing tackle. I still got all these thousands of Legos up here from the days RCX all the way up through the last one, EV3. I didn't go to the Spike. We didn't do Spike.
And our friend Pam in Portland would also be sad if we did not mention that we do host high school interns from First in our Portland office who actually work on a program that's called Synthesis, which is meant to be each year Autodesk works with First in order to help make the competition more equitable by creating a simulated whatever the field is each year. They kind of simulate it, make it a simulated environment so that teams can, some teams have the ability to create multiple robots, so it makes it kind of unfair, if you don't have those resources. So by, creating this simulated environment, it allows you to, particularly if you CAD'd your robot, to upload your robot into the field and test the field in that way too.
So we have a question. We've actually got a number of questions about why can't my country participate in Make It Bridge? So certain contests we are unfortunately restricted to where we can run them, but we have a Fusion 360 3D printing contest coming up Monday. Actually, it's launching, and that's open to all students. And most of it's it's open to all students worldwide in most countries. There's also a number of other contests on Instructables that are open more or less worldwide, minus some countries where there are embargoes and restrictions. But yeah, we're sorry that this one in particular isn't, but you should check out some of the other contests because we're constantly running more contests on Instructables that you can enter.
Any other questions, Randy?
Let's see. Oh yeah, here's the question. It seems to have been answered in chat, but I'll ask it here anyway. Basically, is there a clear webinar or a set of instructions for exporting from Tinkercad circuits into Fusion electronics?
I wonder if that's going to be covered in, and we are starting these series of Fusion webinars. Do you think that is electronics being covered in that?
As far as I know, there's no immediate plan, but I agree it would be a great thing to have.
What was the question again? Moving from Tinkercad circuits to Fusion electronics?
Yes,
we support that. There is a send to Fusion within the Tinkercad circuits. So all the stuff, that Kevin or Donald was showing in the circuits editor, you can actually export that right into Fusion if you have Fusion installed, and it opens in electronics. Another cool thing that we didn't show in this webinar is that it also sends over a schematic view of your circuits, which is an extra sort of free thing you get, and which Fusion electronics uses to reconstruct your circuit. And over on the Fusion side, we have the equivalent for all of the components you have in your circuit. We recreate the 3D model there, so you can visualize that and reroute traces and things like that. So it's quite robust. You're into that.
Yeah, I'll second that. Once you send the schematic over, you should be able to follow any tutorial that already exists for Fusion. Like the process of sending it over is actually quite easy.
Yeah.
Right, well, it is starting to get late for our East Coast friends. It looks like Pepper behind you, Kevin. I think that Pepper fell asleep. And I think that Baxter's been asleep for a while too. So we don't want to keep the robots up too late, because I know, Kevin, you need them in the morning, right?
Stay busy at Mass Robotics. Bring students, they're always here.
Yeah. All right. Well, I just want to, before we go, I just want to thank everyone for sticking around. I want to thank our wonderful, wonderful guests for teaching me so much tonight. So Kevin and Donald, it was amazing. I feel like circuits is the environment that I feel the least confident in, but I feel like I've gained confidence from learning from you both. You're such wonderful teachers. And thank you to the extended Tinkercad team for sticking around and sharing the awesome code blocks demonstration as well for us, Christian, and for answering everyone's questions. And we will see you on May 25th for our season finale. But until then, happy tinkering, and we will be in touch with the slides and with the certificate and with the recording. So hang in there, take care, and we're going to end the webinar now.